I'm going to show how to use Desmos as a tool, remember, to check your answers. And again, I would definitely use this just to check my answers to see if they're correct. You could use this to help guide you to the right answer, but definitely always remember showing your work is the best bet. All right, so we're going to talk about systems of equations. So we've got two equations. I'm just going to make up a line 2x minus 4 and a line of 1/2 x, whoops, come out of the bottom here, minus 3. All right, so it's graphed my two lines. One's in red and one's in blue. So I can move my graph so I can actually see that point of intersection. And if you take a look at it, it's not in a very pretty spot, but if I click on it, it tells me what my answer is. So looks like 2/3 and negative 2 2/3, which is, that could be an answer that we could definitely come up with. We'd have it probably as a fraction, so you would just need to know what fraction corresponds to this decimal that they're giving you. So that's an easy way to check. Again, you can use substitution or elimination. You need to be able to get your equations into y equals mx plus b. I'm curious to know, let me delete all this. If I do 3x plus 6y equals 2. It will graph that for you, so you don't even have to solve for y. This is crazy. And then my second equation, I can do y equals negative 1/2, oops, forgot my negative. Negative 1/2 x, let's see here, plus 3. So if you notice, those end up being parallel lines, so they don't have a solution. So that's pretty cool, and I can get rid of that negative, and I can see that this one intersects at that point. I can make this a 1/3, so they intersect at 0 and 0.3. So you can definitely put in standard form. You probably put in any kind of equation here. It doesn't even matter what form it's in. I bet you it will graph it. Yep, look at that. It will graph any equation in any form. That is awesome. So you don't have to worry about solving for y. Desmos is an awesome tool to use to check your work. In math 2, we do nonlinear. Oops. So if I do something like 2x squared plus 3x minus 4, and I want to graph that with a line, 3x minus 4, something like this. I could see where they intersect at. Ooh, that's a very tight intersection. Looks like it's, yep, right there. So they intersect at that y-intercept of 0, negative 4. I could change this. If I change it, they never intersect. If you notice, my line and my parabola will never touch, so that one has no solution. I could play with this a little bit, and this one's going to have two solutions. You can see one's here at 210 and one is here at negative 2, negative 2. So I would do substitution or elimination and solve this, and you would end up with two answers. And then I would come into Desmos, type it in just to verify that my answers are correct. Super cool. Another thing that we can do instead of parabolas, we can take a line and a circle. So the circle equation is x minus h squared. My typing skills are not on par today. Plus y, and I'm going to make that a plus 3 squared. And then I'm going to do a radius of 16. Actually, it's a radius of 4. Squared gives me that 16 value. So really, I could just make this a 4 squared just to comply with the equation of a circle. So it's x minus h squared. So this is to the right 4 and to down 3. So my center is to the right 4 and down 3 where my cursor is at. That's my center. And it's got a radius of 4. So we'd go left 4 from the center, up 4 from the center, to the right 4 from the center, and down 4 from the center. And that creates your circle. But anyway, if you notice, my circle and my line never intersect. So you would say this has no solution. And again, I can change my equation of my line. Let's see what I can come up with. Oops. I keep saying whoops a lot. All right, so say I had 1/2 x minus 6 graphed along with this circle. Again, you can click on the points of intersection. It intersects twice. And there you have your solution. can be found by substitution elimination. It gets very gnarly, but Desmos does it very easily and very quickly, as you can see. It's pretty cool. So that is systems on Desmos. Hope you have enjoyed my tutorial. See you next time.